Hi students, welcome to HSC Chemistry and the Chemical Monitoring and Management topic. This is video number 25 looking at water purification. Now there's a couple of important sequences that you need to be aware of in terms of the way that water is treated before it reaches our taps. And there's two main methods. The first method is a physical, or involves a number of physical methods of treatment. And these include things like screening, sometimes an adjustment of pH balance for the addition of a coagulant such as ions, flocculation, that joining together, clarification or settling, and also then filtration. So let's have a quick look at each of these in a little bit of detail. The first thing is basically just a net. Think of it as being some sort of a net or a sieve, which has basically got large holes allowing big pieces of debris to be caught. So this can include things like branches that have fallen, but may also include large animals that are rotting that will be filtered out before they go any further into the filtration tanks. Then we may need to change the pH a little bit. Sometimes this is done through the addition of slaked lime, calcium hydroxide solution, which is going to increase the pH of the solution. And what will that will often do is counter the addition of ions, which usually are being used as a coagulant or a flocculant, or flocculant, in order to try and encourage the particles to be a little bit more, to stick together a little bit better. So what we have is effectively, think of it as a suspension. So there's a very large number of small particles, and they are moving about within the solvent, the water, the liquid. And what we want to try and do is we want them to clump. We want to encourage clumping. And in order to encourage clumping, we need to add a substance that is going to help that happen. We also need to give it a little bit of time. So often these tanks are large tanks, and over time you see that often the froth, the flocculant will float up to the surface as a bit of a froth, looking almost like bubbles like detergent. Or this can also settle. So we can use a clarification process which allows our sediments to actually settle. So this process, also known as sedimentation. If it's floating on the surface, we can remove the surface layer, and that will remove a lot of those particles. But we also do want to make sure that we remove as much of these particles as possible. So the next thing we do is we put them in a series of filters, and you'll actually you've had the opportunity to go out to St Mary's and see the treatment plants out there and actually see the cross-section of these different filters that are being used in order to filter out a lot of these larger particles. A lot of these filters have the added advantage that they can be reused by pumping water back through them, reflushing them in order to try and clear out a lot of that deposit, a lot of that sediment, in order that the filters themselves can be reused. Now, after the physical methods have occurred, then we want to go through some chemical methods, and this is the addition of specific chemicals for specific purposes. Probably the most important of these is chlorination, which is added as an antibacterial. It's designed to try and kill some of the most common types of microorganisms that may be present in the water. At this stage also, we may have may need to do a bit of a pH balance, particularly if there's been some addition of acidic or basic substances at some earlier part in the process. We need to make sure that the pH is sufficiently neutral for it to be potable, for it to be drinkable. And also decisions have been made, they get made by different governments with different amounts, but certainly what we have is the addition of fluoride ions for the purpose of dental health. And this has been something that's been added for a long time and has been shown to have a significant impact on increasing or improving dental health as a consequence of the addition of fluorides to our drinking water. So this is a lot of processes, and perhaps one of the ways of trying to help you remember this is with this little acronym SAFSFCAF. SAFSFCAF identifies the key processes that are part of the water purification process. So if you write down SAFSFCAF and then see if you can remember which of these processes are being used in order to work through our process of water purification. If you can identify that most of the ones above this line are physical and the ones below the line are chemical, and then hopefully you can match each of these words up to help you remember the order of processes which occur from the water that we're going to drink coming from the rivers, the streams and the dams actually coming out of our tap. So a lot of processes involved in this, some physical, some chemical, and hopefully SAFSFCAF might help you remember them in the correct order. Thanks for watching.